If you are expecting to go over blockchain, then you're in the right place. And we're going to get moving here. Hopefully, Ed, can you see my screen?
I can.
All right. And Jason, can you see mine?
Yes, again.
Awesome. All right. So the key points for this particular presentation are as follows. We're going to be covering blockchain, and it's very transformative. We think it's as important as the internet was in the late 90s. And we want our industry and you to understand what it can do. The second thing we're going to talk about is an initiative we have. It's the website you've been going to, CUBlockchain. And it's an opportunity to create a blockchain network for our credit union industry that would allow us to quickly deploy applications and increase our ability inside the fintech marketplace to compete, which has been very difficult. Then we're going to talk about an application for this network. And we're going to go with what we think is the ultimate application. And that is, how can we stop the madness of the password crisis? What if we as the credit union industry could help folks not have a million passwords and a million user IDs? Imagine no more passwords to reset. You would be reducing your calls to the call center on all channels. So without further ado, we're going to jump right in. We got a lot to cover. So first of all, there's a lot of hype around this. You hear the hype all the time. Blockchain will cure cancer. Blockchain will, do all of these things. And I certainly would say that I've been part of that hype. However, it is that we believe that J.P. Morgan, Bank of America, someone like Blythe Masters, a Wall Street, wizard in this thing, would not be spending $9 billion for working with blockchain. Neither would Bank of America be putting all the money they're putting into it for building up patents on this technology. So why is it so important? Why do we care? And that's what we're going to try to cover today. If they're spending this kind of money, we need to know why. So the first thing to understand is that Bitcoin is not, or blockchain is not Bitcoin. So we are not here to talk about cryptocurrency. It's the elegant underlying technology that enables Bitcoin. So when the guys built Bitcoin, they needed a way to be able to track every transaction. They needed to know exactly who spent what. They needed to follow every Bitcoin around. They needed to do it anonymously. And so they came up with this elegant solution of a distributed database or a distributed ledger. And that's the technology we want to talk about. It's sort of one level down from where Bitcoin is. It's also known as shared ledger. So we're not here to talk about Bitcoin, although that is a use of a blockchain technology. And there's two different types, which we're going to get into in a little bit. But just to start off, that is an important concept that everyone needs to understand. So today, I'm honored to have with me someone I can call a friend now, Jason Law, Chief Technical Officer. He's the CTO of Evernym, and Evernym is a company that is building a digital identity concept on top of a blockchain technology. And when I started to experiment with the blockchain technology, and I started looking at the things that were out there, I really wanted to find someone, A, who could help me, but B, I just wanted to see what was going on in that space. And I ran across the folks from Evernym who, one, were just totally willing to educate and teach me things, which was great because this is one of the most difficult concepts to understand. And then, secondly, as I looked into what they were doing, I realized, oh my goodness, their blockchain technology is a lot different than the other blockchain technology I've been looking at. It's open source, and I really felt like, as I was from a technical perspective, this was going to be something that maybe we should look into. So I reached out to him, and I would say probably every night since then, Jason, we've probably been up. I don't even know how you're awake right now, but
A lot of late nights.
yeah. And in his between time, he's a CTO of Evernym. He was the CTO of Finicity, so he has some financial background. And in his between time, he takes care of his 6 kids because he apparently lives on a farm somewhere where he needed 6 kids to run this sort of stuff. So, Jason, I'm going to introduce you because I think you're the best one to kind of take him through kind of what blockchain is. So welcome,
Sure.
Jason.
Thanks for having me.
Oh,
Okay, let's jump right in. So I wanted to start with just a little bit on Bitcoin. And what John said earlier is absolutely true that blockchain is not Bitcoin, but it's a great place to start when we're talking about something that's new to a lot of us. So Bitcoin, the Bitcoin blockchain has a public ledger. It's distributed. Everyone has a copy of it. This ledger can't be changed. You can't remove any previous transactions in that ledger. It's anonymous. Uh, I say kind of because there are some privacy concerns around the correlation, ability to correlate the addresses that are used by Bitcoin. It's not encrypted, but it's still secure. And the reason that the name blockchain came about is because the transactions, about every 10 minutes, these transactions are collected, and miners will attempt to solve a cryptographic puzzle for that block. And when that happens, that block becomes mined or solved, and it gets added to the chain of previous blocks. There are the concept of hashes that we'll talk about here, where a new block has a reference, a cryptographic reference to the previous blocks, and in that way, every block is chained to the one before it. In fact, you can, if you were to install a Bitcoin client, you would, depending on the client, if it's the core client, you would have about 75 gigabytes of data that would take you all the way back to the original Bitcoin being spent, and to that to be what's called the Genesis block. Now, the important thing about the cryptography and the technology that's at play here is that a Bitcoin, can't be spent more than once. Obviously, a lot of things that go into play in the financial industry to make sure that our money can't be spent more than once. That's very important. It's secured through cryptography. It's a concept we'll talk about here in a minute called proof of work. And anyone can participate. Anyone can become a miner. Now, I just went through a whole lot of stuff, and I think we could spend an hour, 2 hours just on these concepts. It wasn't meant to overwhelm you, but it's just wanted to make sure that we covered off on kind of some core principles. Let's go ahead and go to the next slide. Okay, we talked about hashes. Hashes can take any amount of data. It's a formula, an algorithm that can take any amount of data and turn it into something that's very small, about, in this case, about 32 bytes, and it's a deterministic algorithm. And so you can have any amount of data. It could be a book. You take the Library of Congress, if you wanted to, and reduce it down to this one hash. Now, this isn't encryption. You are not able to go backwards. You can't take the result of a hashing algorithm and go back to what the original data was. And so there's some very interesting characteristics about this, and this is what a lot of the security of Bitcoin and other blockchain technologies, including ours, depends on. Even the slightest change of the input results in very different output. And I just gave you some examples here. This is actually, you could go online and find for a certain algorithm called SHA-256. You could take my dog has fleas as an input, and this becomes the output. But if you change just that one letter from A to an E, you now see that it's very different. And you have no way of knowing by looking at this hash what was the input, unless you were to take that input and try to get to it. So next slide. And this is kind of illustrating a point here. The hash at the top under, it says example here, that is an actual hash. And about 2 or 3 a.m. this morning, that's the hash that Bitcoin. That's the hash of an actual block of Bitcoin. And you notice that the first 17 characters of this hexadecimal hash are all zeros. Well, that's the puzzle that you're solving when you mine Bitcoin. Is you make minor modifications to your input data in order to hopefully find a hash that has all those 17 zeros. If they do, then you won, and you get paid a bounty of 25 Bitcoin, which is approximately $10,500 today. The interesting thing is that it's hard to do. In fact, if you look at the graph on the left, that's about 1.3 million terahashes per second. Okay, just to give you perspective here. It is a terahash is one with 12 zeros after it. So 1.3 million terahashes, which is a hash algorithm that's run per second. And this is all of the Bitcoin miners working effectively together to try to solve these blocks. And so to solve one block, to get that $10,500 bounty, there's a 780 billion hashes on average have to be performed to do that. So it's pretty incredible.
So my chances, like if I want to crank up a miner and go make $10,500 with my computer at home, do I got any shot at that?
Not a chance in hell.
Right,
I mean,
because
I'm sorry. Yeah, technically there is a chance, but yes.
Yeah, the point is that the difficulty level goes up, and that's what creates the value of the Bitcoin.
Absolutely. So when you look at, and the point I'm making here, I think it's interesting for one. I think it's one of the most interesting experience phenomenons in the world. But the point is that it takes an incredible amount of electricity. In fact,
Yes.
It's estimated about $1 million a day worth of electricity goes into Bitcoin mining.
Right, which is kind of like its balance for the currency.
Right. There's an equilibrium that's achieved, and it's about and if you look at the amount of money spent to mine it, it is reaching an equilibrium to the amount of money that's being created in terms of this 25 Bitcoin. I say money.
So even if I have a computer powerful enough to get one of these things and to find my zeros, I might have just spent $8,000 in electricity to do it.
Yes. Yes.
Or more like, 9,000.
Right. Right. And the interesting thing about this is that it actually encourages consolidation. So you wouldn't do that now. John, you wouldn't go and create you wouldn't go buy these ASIC miner rigs.
No. I would join a group.
You join a group. You join a mining pool. And that's kind of one of the challenges of Bitcoin is that the two largest pools in the world, if those two pools got together, you'd have over 51% of Bitcoin. And so it kind of illustrates, let's maybe go to the next slide. I think I talked a little bit about this in the next one. Actually, I'll talk about it a little bit later, but I'll just mention it now. If you get more than 50% of the computing power of Bitcoin, you've actually now have the ability to double spend Bitcoin.
Wow.
So the security of it depends on that. So all we have to do is have two large pools come together and decide we're going to work together on this. I think that there's also reasons why they wouldn't do that. It doesn't make sense for them to kill the golden goose in a matter of speaking. But that's kind of
why would you game a system that's working for you? Unless it's just for nefarious reasons, there isn't a good reason to do it.
Right. So just in the interest of time, I'll go through this quickly. Bitcoin is proof of work. There's also other mechanisms for getting distributed consensus. Because it's all about making sure that everyone agrees to the same version of truth, so to speak. Proof of stake is another. Proof of activity, proof of burn, proof of capacity. These are other ideas that allow us to get consensus. And proof of stake doesn't cost as much as proof of work in terms of electricity. Then the last one is Byzantine agreement, and this is one we'll talk about just for a few minutes here. Here's an example. Just kind of explain some things. A1 is a general. A2 is a general. They have to communicate by sending messages through the city B. They want to attack the city. But you can see the general has 3 dots. Both generals have 3 dots each, but they both have to attack in order to overcome the city, which has 5 dots. So a message is sent from General 1 who says, hey, let's attack at dawn. Please let me know you got this, because unless I know you got this, I'm not going to attack. I just want to make sure that we're on the same page. He sends a messenger to the city, and he gets it, and he says, oh, awesome. That sounds good. I agree to your time to attack. But by the way, if my messenger doesn't get to you, I don't know if you're going to attack, and so therefore I'm going to make sure that you tell me if you've got my message. So General 2 writes, sounds good, let me know you got the message. General 1 writes, okay, I got your message, but let me know you got this message, because I don't want to go if you don't know I got your message.
Yeah,
okay?
And it's this loop of, I'm not going to attack unless I know for sure you're going to attack, and we can never sort of solve that problem that we guarantee each other has been communicated to.
Exactly. So this is what's considered, it's a classic computer science problem. It's considered unsolvable. Okay. So next slide. All right. So here's kind of similar situation, but now there's 4 generals. This is a protocol, a family of protocols called Byzantine fault tolerance. So no generals trust any other one general. Each general independently decides to attack the city at dawn if 2 others, or at least 2 others, also commit to attack at dawn. So now we've got a distributed consensus among a larger number. With 4 generals, we can have 1 faulty general, and we can still come to consensus, because we don't need all 4 to actually do the thing.
And by faulty, you mean 1 general that didn't get the message and may not attack.
Right. Any kind of fault. So he could be asleep, he could be nefarious, he could have been turned by the enemy.
Right.
Yeah. So for any reason, maybe he just didn't get the message. So this actually solves the problem of, in fact, this concept is used on airplanes. They have Byzantine fault-tolerant protocols where they have multiple systems evaluating the inputs to decide if the inputs are valid and to make the necessary changes in their flight control systems. And this is how systems, they can't go down like moon launches. They actually implemented some of these kinds of techniques.
Interesting.
All right, next slide. So quickly, there's really two major types of blockchains. There's the permissionless side that we talked about earlier. Bitcoin falls into that category, and it's a great example. Permissioned is now with a Byzantine fault-tolerant protocol like we just talked about. Now we have a different option, a new option that actually gives us some nice benefits.
And just for the folks on the phone, when JP Morgan and all these people talk about what they're setting up, they're all talking about permissioned, correct?
Yes.
Okay.
Yeah, there's advances happening on both sides of it, but where the money and the talk is really happening and heating up right now is on permission.
Okay.
Permissionless, anyone can play, anyone can spin up. In a permissioned blockchain, like we built a consensus protocol called Plenum, and Plenum implements a form of Byzantine fault tolerance. It's actually a variation on one called redundant Byzantine fault tolerance. And Plenum is the basis for our identity platform Sovereign. And so what we're doing is, because we're permissioned, there's a governance protocol that helps us determine who is allowed to be inside of this consensus pool, this pool of generals, so to speak. And these would be known and vetted validators, for example, credit unions. In fact, we have some that are coming up. So on the left-hand side, we've got permissionless. Governance is in the code itself. It's really more about Go ahead.
And any Yahoo can play. I could fire up my old 486 and get rolling, and then I could be part of that network.
Yes, and if you had access to enough computing power, you could actually. And I talked about that earlier. This mining pool
could overtake it. Yeah, well, we could create that issue that we had. Yeah.
Sure. Usually, it's a proof of work and permissionless. In permissioned, it's usually in some form of a fault-tolerant protocol, a Byzantine fault-tolerant protocol. Permissionless usually requires a cryptocurrency to kind of control the flow of transactions. Permissioned can be private or public. There are variations, kind of along a spectrum.
Let me explain that for a second. So what that means is that it could be running in a network that no one else can get to, but the people who've decided to participate, right? So we could say this is a closed network, and only like an ATM system is a private network. We don't put those out on the open web. But we can also, because of this thing is so powerful from its encryption, we can also run them in the public, meaning that we don't have to have a secure network. You could literally run them right on the internet, still behind the firewall, but you could open it up to the internet and not have to build a bunch of networks to everyone.
Right, and there's use cases that work for a public permissioned blockchain. There's also use cases that work for private, where you could have a consortium of 4 or 5 organizations that say, okay, we're all going to communicate using this system or interact using this system, but no one could get into that system except for those people. So that's a permissioned blockchain.
Right.
The permissionless and the big advocates for permissionless often cite censorship resistance. And I'm a believer in this. If you have a system that's a public system, you don't want to have one party being able to limit the participation of any other one party. That's important for certain types of applications of blockchain.
Like voting.
Like voting, exactly. For permissioned, however, you do have some control of the validators. And so what happens is it becomes very important to put in place a governance protocol that basically who guards the guards. And so this is the area that we're doing a lot of work in right now. It's very exciting to be able to create that governance that allows us to have, for sovereign, allows sovereign to have an identity that spans borders.
So real quick, you work for Evernym, and then Evernym has a product or platform, called Sovereign.
Right.
Okay, now, we'll get to that.
Yes, yeah, Sovereign, yeah. Well, so you're going to talk a little bit more about that later, right?
Yep.
Great. So I guess to wrap up here, permission has some nice advantages. One of the big ones is that it's a lot lower latency. You can have a confirmed transaction in a permissioned ledger in a few hundred milliseconds. In a permissionless ledger, well, you can have it faster than this, but Bitcoin is the great example. You can have a confirmed transaction in about 10 minutes. You can have a strongly confirmed transaction that you could never, millions of dollars could be transferred, and you would never, the chances of it not working or being changed later are down to the smallest fraction. So that would be about 6 blocks, which would be about 60 minutes. But you can have, with permissioned, with Byzantine fault-tolerant protocols, you can have it in a few hundred milliseconds. You can also have drastically higher throughput. Bitcoin has some limitations in kind of how it's implemented today. I think that there's a movement to try to remedy this, but you're really looking at about a max of around 7 transactions per second.
So to close this out,
permissioned
is, you just talked about an hour versus 100 milliseconds.
Right.
That's why JP Morgan is more interested in permissioned than they are permissionless.
Absolutely. Yeah, next slide. Thank you. Just really quickly, a note about privacy and correlation. This is a big big deal for us at Evernym as we're creating this blockchain. It's really important that when we're dealing with identity, that I don't have someone else being able to see that I am interacting with one party versus another. I use the Ashley Madison breach as an example because there were a lot of people with sensitive information that was divulged. It was one of the more public ones. I don't care if people know that I shop at Target, but I probably care if people know that I shop at Ashley Madison, right? So this breach, was very interesting because if you really delve down into what
Just for everyone's, Jason's not
Sure.
supporting Ashley Madison in
I'm
any
not
way, shape,
supporting it in any way, shape, or form.
right? Just in case your wife later.
Right. No, I probably should use a different example, but it's such a good example of how a data breach can be quite have big impacts. But it's important, I think, to know that what happened there did not have to happen for a number of reasons. Even with traditional securing of the information, with a sovereign blockchain, you can actually make it so that the information that you share is only enough information to actually confirm the transaction. Think of this as an example. I have an ID card and I go to a bar. When I give my driver license to the bartender, I'm giving him quite a lot of information. He knows where I live now. He knows my actual birthday. He knows other information about me that I don't think that he really needs to know. All he really needs to know is that I am over the age of 21. That's it.
And that the government has confirmed that you're over the age of 21.
Yes. And so some way of identifying me with some sort of picture and an attestation from the government that says I'm over 21. Nothing more. And so what we're doing, what we're building is a way to do that so that when Ashley Madison said to its customers, here, give me all of your information, including your address, right? Your name, your address, your billing zip code, all of that stuff. That's not necessary. I mean, with sovereign. So anyway, this, I won't go into details here because I think we might be tight on time, but
and we'll be covering that a little bit later too.
Yeah, but these it's very important, and there are mechanisms and capabilities within blockchain that solve this privacy and correlation issue. So
well, there were things that were impossible yesterday that are now possible today because of this technology.
Absolutely. And I'll just make one more point on that. You see at the very bottom, it says forgettability.
Mm-hmm.
There are, with Byzantine fault tolerant protocols, you have the ability to take what people think is kind of a cardinal rule of blockchain, which is immutability. You actually do have a way to have certain portions of transactions to be mutable and certain portions are actually mutable. So, for example, when I say a transaction, let's say that I change my name, there should be a way for me, especially with privacy laws and regulations, especially those that are coming out of Europe, that I think will start to show up here. In fact, some of them should, because we do
A battered woman or something like that that's trying to, escape, and yeah, there has to be that built into it. And when you say immutable versus immutable, the idea is that immutable means that that's a ledger, it's solid, it's been chiseled in stone, it will never change. But mutable means that we can go in and change certain aspects of it.
Right, but it's all within some very, very tight bounds. Only I can do certain things. Exactly.
Right.
So I think we're good on that.
Awesome. All right. So,
okay, go ahead.
Yeah, I was going to run us through here. So this is a big picture. I'm a picture guy. I'm from Missouri, so it's the show me state. So if I were looking at like the transfer money through the blockchain, and this, let's not worry about Bitcoin. Let's just talk about transferring some cash. So I've got Crayon A that wants to transfer to Crayon B. So I say, okay, I'm going to transfer $1,000 to, from Crayon A to Crayon B. So I hit it, it goes out, it hits the blockchain, it gets configured into a block, and then it's broadcast to the entire network, meaning every single node that we talked about earlier. And a node is a particular server or a particular system that's running. And every single one of them gets it at the same time. It's not like you pass it to one and then it passes it to the next and it passes it to the next. All of these guys get it. And once they get it, they validate it. And when it's finally validated, and I'm on step 4 here, then it's tied to this chain and says, okay, here's that $1,000. It's coming from credit union A, and I'm convinced that it's true because all of these different systems accounted for that, and we'll get into that a little bit later. And now I can just, as counter B, as credit union B, I can go, yep, this is for sure the money that came through. It's guaranteed, identity-wise, that, and we'll get into that it came from credit union A, and I could count on it. I can count on it. I could spend it regardless of settlement. I can move into that space. And we're going to talk about more of what these things look like in some other technology. But this is, this is from Goldman Sachs, but I really like this picture because it broke it down into 5 easy steps. And by the way, we'll be giving you all these presentations. They'll be out on CUBlockchain. Also, the movie, for those of you who may have joined late, we're not filming this, but recording it. We'll have that out there as well. And there's a second piece coming up. We'll talk about part 2 in a little bit. So why is it valuable? Why do we care? Well, first, the data is guaranteed. It's stored on so many servers that it's going to be there, and you're going to have availability. You'd have to take down a whole lot of servers to make this to break this. You can run applications on them, and one of our biggest issues is in the credit world is uptime. I know there are folks on this phone that live in dread of their home banking or their mobile banking going down. And these applications, as they become more and more part of our lives, and the financial institutions, the credit unions are on the hook for making sure these things stay up forever. And this thing is extremely redundant and has an extremely high uptime. You can run applications very, very far into the future, and that speaks to that chain of blocks. That there's this permanent history. And there was this great video we were watching the other day. Jason and I were up at some late night, and the guy said, you can track in the blockchain of Bitcoin all the way back to the very first transaction. So some point, 5 people put one up and said, it's time to go. And they did their first Bitcoin transaction, and that sucker is still in there on the ledger for people to go and track down as a source of truth. So the other thing that happens is because this entity doesn't go away, it sort of lives on, then it can go very far into the future. You can you can maintain these things because it would take so many people to go down, and I'll talk about that. One of the things that the blockchain is becoming well known for is being sort of an honest application, in the sense that because it takes so many nodes to come to consensus, the application's logic is honest. And when you think about contracts and things, which I'll get to in a little bit, it's starting to have this sort of connotation around it. So that's kind of a neat feature, particularly from a financial standpoint, as trust is what we sell. And here's a big one. Any of these applications can talk to other applications with almost 100% reliability, even if the underlying platform is only 99%. This, again, is because of the redundant Byzantine fault tolerance that Jason was talking about, that even if a couple of those generals get picked off, we got plenty of other generals, and as those numbers go up, you get amazing statistics on uptime and reliability and communicating between them. So these are all things that we've seen before. And the final one is you can build applications. And you're going to see a little later, we built one already. We're going to share it with you and show you what we did. And it really wasn't that hard. And it's already connected to Scimitar's core. It's pretty interesting, and we'll talk a little bit about that. So why do we care? What's the potential? Well, I'm going to go over some apps. I want you guys to dream with me a little bit for those of you who are listening. So first one is smart contracts. There are a lot of QSOs out there that do indirect lending. We're going to see more as we see the marketplace lending. So this is what it would look like. Imagine that a member walks into a dealership and they know their contract number and they're ready to buy this car. And instead of sitting down in that glass room with the dude who tries to sell me all the other stuff and makes me sign everything, we work through in what's called a smart contract. And that smart contract is sort of an if then else kind of a thing that says if you do this, then this happens. But there's a whole lot of other stuff that can happen. So I sign the contract, it hits the client. That contract says, okay, in blockchain, is this John Best, and is this the contract? Is this the real contract? And 1,000 nodes say, yep, that's John Best, and that's the contract. Once we hit there, the credit union goes, oh, okay, well, Now I can sense, and they don't even have to do anything to make this happen. A credit blockchain application will say, yep, I see that John has said that he wants to get this. He has accepted our gap insurance, but I'm going to need his wife to also sign. We're going to need a joint. So we send back that. It goes through the blockchain. It hits the smart contract. We get the key match. We know it's still the same person. We get the contract update. And my wife, who's standing next to me with her phone, uses her fingerprint to say, yep, to say, yeah, I'll be a joint on this. And the dealer flows through this. And let me tell you, I'm not that smart. So if I can figure this out, we have JP Morgan, Bank of America, this is what's going through their head. How do we take things like real estate? How do we take asset-based lending and make it much faster, much more efficient, and much more secure, and remove a lot of the risk? And that's what this thing is almost, in some ways, custom built to do. But it has other uses, like we talked about, the assets. I don't know if any of you have ever sold a car that you owned. I sold a car the other day, and I got the title finally. And here's how you sell a car to someone else. You flip it over, and on the back, you break out a pen, and you write down any Joe Palooka's name that you want and how much you sold it for, and then you hope that they take it down to the DMV and they don't run off, or you take it down to the DMV to get this asset tracked. That needs to change. Titles could be really well handled in this space. I was once in New York City around May in 2012, I think it was, and somebody pulled a blue Pathfinder up. I remember because I used to own a Pathfinder when I was a kid, and turned out it was full of bombs and explosives. I was very fortunate that I did not blow up that day in downtown New York, but they could not figure out whose car that was. The guy had scratched off all the VINs, he'd done all these things. With something like this, we'd have been able to track it, instantly right there once we found any part number or any asset created with that. Clearing and settlement. We just talked about that earlier. We used that example. Instant reconciliation. Members do not understand holds. They don't know why when they spend money as a credit, which we beg them to do for interchange, that it shows up as a hold instead of an actual transaction, unlike debit that comes out right away. I can tell you that the Fed's Faster Payment Task Force, there will be blockchain applications that will be submitted for those of you that are following that as a possibility for this. We're also going to see people like Clear Exchange, so which is a conglomeration of banks that also owned Early Warning. We think that they're looking into this. Well, we know they are, and also possibly the clearinghouse. So we're going to see more of this come together. And then payments. There's lots of opportunities for payments. You can see how a tight contract between two people about a payment. Imagine rent or something like that just automatically pulls out, guarantees it. There's going to be a lot of those sorts of things. And then the big game, which we're going to talk about in a minute, digital identities. So this is where we can talk about the CUBlockchain concept, a credit union owned and operated blockchain network that every credit union could participate in and profit from if we choose to get together and build it. In the past, whenever something like this has come up, we've kind of gone our separate ways. Some credit unions go off or some folks decide they can go do this, and some folks decide they can go do this, and then we spend years merging and converging and creating integration. What I'm telling you guys is, and what my message to the credit union industry is, let's all get on the same system. And even if we're wrong about whatever system that is, because we're all on the same system, we'll be right. Because whatever becomes the best thing, whether we win or someone else wins, we won't have to worry about moving everything all at once or in small blocks. So imagine this network that you see to the right. There's these large QSOs that are running supernodes, and all the credit unions on this phone could have a node at their shop. Matter of fact, we're going to talk about that in a minute. And every one of you could be running all these different applications. Think of it like the Apple App Store of blockchain apps. And I'll kind of get into that. So our goal is to make this easy, to remove barriers for your credit union to sort of participate. We want to normalize the platform before we start creating applications. Let's make it so that we don't have to all spend money on integration for everything that we do. Let's try to reduce that as much as possible from day one with this technology. Let's create application interoperability among all credit unions and credit union entities. We don't even care what core you're on, what third-party products. How many times have you want to look at something and they, oh yeah, we don't have that core, we don't have that connector, and then it's a lot of money. we could actually pre-plan for that and have a way to normalize those things, no matter what your entity type is, no matter who you are. Every single credit union affiliated entity can participate. And the idea is we're going to go through and we'd like to get some folks behind us to say, hey, CUBlockchain, we're going to look at Ripple, Ethereum, Bitcoin. We could be running some of these things on our systems. We also have Plenum, which we're going to talk about in a minute. And as credit unions, if you have programmers, designers, product management, researchers, and funding, we can get together and open source this and create a network. And we've got a lot of folks behind us to talk about. As a matter of fact, one of the pieces that we've looked at is from day one, we're going to be CUFX compliant. For those of you that don't know what that is, it's a standard for credit unions to make sure that everything can talk to everything else and save money. You can go to cufxstandards.com to check that out if you haven't already been there. I'm sure many of you have already heard of this. Why not make whatever blockchain we choose, which I think Jason's technology is amazing, but it may not do everything we want to do for some applications, and there's no reason why we can't use other things plus that. So we have to think about that as we're building this. But because we're all credit unions, and because I'm going to go back up one, because we all collaborate and we all have these data centers and systems, we have a tremendous opportunity to create a blockchain network that we could run applications on. So imagine this is my proposed governance and monetization concept, something we've been working with a lot of folks in the industry on. The idea is that there are QSOs, there's core applications, there's fintech providers. They're all going to want to take advantage of this blockchain network because it makes their products better. And so they want to put that out there on our big giant credit union blockchain network. So they go to one of the large QSOs, Co-op, PSU, TMG, any of these guys, and their job is to certify the application, make sure it's the security is tight, make sure the design is well, and that it's going to work on this network. And they get to make some money by going through and doing that and vetting it, and we'll have lots of groups that can do that and making sure it can work. When they're done, the licensor takes it to the registrar, just like getting a domain. And we do own CUNA owns the .credit union domain. We've been talking to them about this. These guys say, okay, that's great. We're going to administer this application. We're going to roll it out to the credit union network, and it's going to have some concepts. It's going to have some features in it that we understand. They're going to make sure the network's administered. And here's the best part. They're going to disperse the income because they're going to have to collect from these fintech providers for using our blockchain network. And we don't want to make it crazy because we want all the applications and the utility and the features that we could roll out to our members. So they're the ones that get that application out to the nodes and help us monitor the nodes. And then there's the credit unions. The credit unions that could be running these nodes at their site. A little more than just a couple boxes that are there that you keep up, you maintain, you use your electricity on, just like he was talking about with the Bitcoin, that are running these things. And once these things are run, then we'll have the opportunity to have a whole lot of nodes and the ability for people to deploy to them. And as we see new fintech providers and new things come up, like I was mentioning that lending application, or we can develop them ourselves. It's an industry. The sky's the limit. But the first thing in this chicken and egg syndrome is to have a network of nodes that you can run on. Bitcoin has that beat because any Yahoo can jump in there. But we could create a permissioned private credit union network that we could all benefit from. And so that's the industry opportunity, one of the industry opportunities that I see. So now, if we were to say that, what would be the best application for us to deploy first? And we think it's digital identity. And here's why. So let's look at how home banking is running right now. So when we look at home banking, our credentials, sometimes we don't have control of them. How many times has somebody converted from one application or one platform to another, only to find out that every member in their entire organization has to do what? Get a whole new password. Sometimes when we do have them, we can't seem to use the credentials for other things. So as we get more and more channels, we're going to have a need of validating and authenticating everyone who comes through that to other channels. For example, our Amazon Echo, which we have demos on our website. You see it. That's my plug. I'm done. The other issue is MFA. So we've got dysfunction between devices. We're continually playing catch up with the regulators, and it's super costly for the integration. So if anybody's ever said, well, gee, we're going to put MFA on our tablet, well, then what happens when we break out, the Echo, and we have to do that because as financial institutions, we're regulated and we're bound to the FFIEC regulations. And then finally, all the money we lose from illegal activity related to identity theft, related to password theft, account takeover, the phishing, the ACH fraud, the bill pay fraud. We've all seen it. Everyone, if you're a credit union on this phone and you have a home banking concept, at some point you've been through this. It's no secret of it. It's just life, but it doesn't have to be that way. Now let's look at what the member's life is. Too many passwords and user IDs. That's the first issue they have. Information is everywhere. So you got your address, you changed, I moved recently. I spent a month trying to figure out all the places that I had to change the address. As Jason pointed out earlier, websites are collecting and monetizing our information in a big, big way. Just recently, Uber put out a way for you to use Starward points or get Starward points for if it is that if you use Uber. And if you look at the fine print on the license, it basically says, oh yeah, and by the way, in return for this, Uber is going to tell Starwood every place they ever pick you up and every place they drop you off. But you have to know, you have to see that. So, and then finally, payments are a hassle. We've, oh my God, we got a new card. Now I got 20 places I got to go put a card in. So these are things that members really, really struggle with. And so how can we look at an opportunity to maybe fix that? Well, the first one is there's already people out there, and I see some questions, and we are happy to stay on. I'm happy to stay on and answer questions past the hour if anyone wants to do that, but I also want to recognize we'll get to the end of this and we'll stick around. And we are going to be doing a part 2 of this, so hang on to those and we'll come to it here. So what's out there today to solve this problem? Well, you can sign in with Google. You can sign in with Facebook, LinkedIn, Reddit, Windows Live, our buddies at PayPal, Instagram. All of these are called OAuth applications. But what do they really know about you? Whoa, that is Ed's actual ID. Okay, guys, well, you can go talk to Ed. Did they check your license when you signed up? Well, no, Facebook didn't check my license. Did they, did they do any other kind of check around you? What they really know about you is your pictures that you uploaded, your tweets, what you like to eat. But let's talk about this. On the internet, no one knows you're a dog. People are using this ability to masquerade as other people for despicable things. There's the child pornography, all of these things that are going on in the underworld and around that. And I'm not saying this is going to prevent it, but it certainly will help if there can only ever really be one John Best on the internet. So who would be a perfect person to validate me, to say yes, to tell Amazon that I'm John Best? And if I was Amazon, I would want that. I would want to know that someone in the world could say, yep, that's for sure him. So, well, I believe credit unions can. We checked your license. We did a no-fact check. We checked your credit. We've got the whole know your customer piece. Heck, we looked into your eyes in most instances because you came in. And we can attest to each one of these things. And we've been forced to do it. It's a lot of work. It actually, many of us struggle to bring new members in just because of all this that it takes to build an online membership application. I don't know of any credit union that's growing at the speed they want, because of these issues. It's a lot of hoops to jump through, and many members check out before they get to the end of it. So how can we leverage this? How can we turn this from a weakness to a strength? We already know and love our members. They are precious to us. What if we could become their authenticators? What if we could change the way we look at things now? So this is your credit union core system today, and it validates your password. And that's great. It's one system. That one system says, yep, if I get in, that's John. If someone hacks that system, we're all in a world of hurt. We know that. We're protecting this as best we can. But what if you had a whole bunch of core systems everywhere? And not only that, but each one of those systems could basically be talking to each other whenever a change is made. Okay, so that does disperse it a little bit, but we still have the problem with the password. This password's kind of still in our way. So let's talk about how we might move identity. So on the right, we have a digital, I think that's digital Fred, and digital Susie. And so first, we've got the core system. We're going to transfer their identity into this sovereign network, which sovereign means that it's yours, it's you. And it'll be spread out through this whole network. Then we're going to move that into those blocks, if you remember those blocks. Well, those blocks are only going to be, it's digital Mike, I thought it was Bob. I struggled with the name last night. And that Bob is the only one that can get into it because Bob has the crypto key. And the same is true for Susie. So now no one else can get to this information. The credit union just needs to know that Bob is Bob. And because Bob has this key, Bob is the only one that could say Bob is Bob with his devices or his systems that he has basically created with this key. And you might recognize this key as being maybe a weakness in this point, but it's actually not because it's so much stronger with a password. And it'll be two-factor every single time someone logs in, but it won't feel like that. It'll feel very quick and easy. And we're going to demonstrate that. So now we've got a core system that validates your identity, but what we actually have is more than one answer to every question. Every time you log in, we can have hundreds of core systems make sure that you are you. And it's not really cores, it's really more the blockchain, but I use this as an example. Okay, so that's great, but John, what if people start hacking this thing? Bad people are out there. They spend all day trying to attack this thing. Well, you're exactly right. But because of the general's protocol, we can actually have a number of them. If you think about this, if we had there are over, I think, 8,000 credit union entities out there. If we had nodes at just those 8,000, in order to bring this down, Jason, how many of those nodes would someone have to get through their firewalls, get through the whole thing and hack in order to cause us a problem?
You said 8,000?
Yeah.
Well, it would be about a third. About a third could actually stop the system. Couldn't take it over, but you could stop it.
You could stop it. And so you'd have to take out a third of these, each with different passwords, each with different firewalls, each with different security, and you'd have to overtake all of these all over the place all at once. It's not impossible, but it's much easier to take out one system that's working on your core. This is the essence of blockchain, and this is the essence of the identity. I struggled with how to display this, but this is what I came down to. This is the essence of it. So why is this better? And we're going to demonstrate this than what we have today. Well, they use biometrics to sign in. We're going to see that. There's always two-factor, but it feels like one factor. It uses an encrypted key instead of a password. You are your password. It's your password. It's your data. Sovereign has no access to your data. So digital Mike and digital Susie, Sovereign can never go in there and sell that or do anything with it. The only person that can distribute your data is you. We're going to monetize privacy. And we as credit unions have never, ever sold our data. I don't know of one credit union that's done it. And as a result, we are in a position because we are trustworthy and honorable, to do something different. So your password can't be stolen because there isn't one. And no one system is validating you. And you can use it elsewhere if we succeed as an industry. So let's look at that. This is how it looks like today. If you log into Amazon, you got to give them all your information. And there's me and you and all these little dots all around here. But that's a problem, because the reality of it is that Amazon doesn't really want my information. They don't like having to protect it. They spend billions keeping hackers out of their system to protect my address, my information. But what if it were reversed? And we talked about this. We've got new addresses, expired or lost cards, everything all over the place. And plus, Amazon can track me. I don't know if you've ever looked at something on Amazon. One time I looked at this thing called a squatty potty, and now every page that I go to in any other site has a squatty potty on it. Pretty embarrassing. That's why I don't surf the web on these webinars anymore. But let's say that we went the other way. What if you were the big circle? What if that was your data and you allowed other people in? And that's the new model. That's the flip. That's the paradigm. That's what makes Sovereign different. That's what makes their blockchain different, in my opinion. And this is a tremendous opportunity as a credit union. So now you can have a presence of your own. You become the source for everything. You're the only person that can do that. But to see it is to believe it. So we're going to actually show you here. So right now we have in CUBlockchain, we have 2 nodes running at Big. We have 4 nodes at Sovereign. And we have one coming up maybe today. It may already be up at Washington State. Next week, if you see this slide, it's going to have probably 7 or 8 more credit unions in it who are bringing up their nodes now. And if you want to bring up a node, it's not real hard, and you want to be involved in this, just, we have a way to do that at the end of this. So if you want to participate, it doesn't cost you any money with the electricity, and you want to see what this looks like, you're welcome to contact us and help us grow what we're doing here. We're not going to charge anything. We're just going to add you to it. We talked about the governance model in the space here. So let's see it in action. I'm going to hand over control to Tom Stacy. Tom is our chief architect here at at Big, and he's going to show what this looks like. So let's take Tom here in the staff piece. Actually, I don't see Tom in this list. Can we make him a panelist? Where's he at? Let me find him here. Oh, I think he's one of the other people here. Okay. I am going to assume that this is probably Tom. All right, Tom. Let me know if that pops you up and if we can hear you.
Okay, can you hear me?
I can hear you. I can see which one you are now. I'm going to make you the presenter. All right, Tom, show us what it's like.
Okay, can you see my screen?
I can.
Okay, so what we're seeing here is this Suncoast Credit Union is a big credit union down in Florida. They've agreed to allow us to use their a version of their site as a demo here. This is not the live Suncoast site. It's intended to show you what this would look like in a real environment, though. So the idea is that the members coming in, they're going to try to log into home banking. So they go to log in, and what happens is they're presented with a standard sort of interstitial page that explains that they've got a chance to change how their identity works. So assuming they're happy about that, they continue, and they're going to go ahead and put in, this is a validation to us, to make sure that we know who they are. One thing to note on this is that these are actually, when I click continue here, it actually goes to the Scimitar, a test Scimitar host to validate these credentials. So
yeah, that's actually on Sim Exchange, and this would be how a member would normally log in, is to go out and hit this Sim Exchange system.
So once the credentials are validated, this is an example of information that could be pulled back from the host now that we're logged into the host. You can pull back their MFA information. So this allows us to do a step where we do a standard sort of thing where we send a text to a phone. I just got that over here.
Yep, 337798.
Yep. 337798.
And this is nothing unusual. We would expect all that.
Yeah, the next step here, we're putting in a 60-digit PIN, so I'll put in 6 5s. And
Which it wouldn't let you do if we were truly making sure that the PIN was, something secure.
Right. But the point of this is that later when we're going to log in using the Evernet application, this would be one of the ways you could identify yourself. You could either use your PIN, or you could use, if you set up the Evernet application to use fingerprint authentication, you would use that instead. But this is an example of some data to store in the blockchain. So the next step is that, and the idea is that we wanted to have something here to show you what's going on step by step. Certainly in a production environment, what would simply happen is you'd skip to what's going to be the next screen where it says, hey, you're finished. But we wanted to be able to have a chance to show you step by step what's happening when we're setting up this sovereign identity.
So we wouldn't normally show any of this stuff to anybody. You wouldn't see this on any screen.
So the first step is that we store this in the blockchain, and then Jason, if you want to let them know, give them a brief account of when I click that button, what exactly happened.
Yeah. So there's a client that talks to the blockchain and then encrypted that has keys for Suncoast that allow it to sign a transaction that gets applied to all of the nodes in the blockchain, all of the validators. and they all come to consensus. And we wanted to be able to show this, but we didn't, right before the presentation, we didn't have a way to show two different screens. What Tom's doing, what I'm doing, so I couldn't show you. But there are 4 or 7 nodes that are validating that one transaction and coming to consensus on is this correct or not.
So this data has been stored in an encrypted format in the blockchain. Now, when I click on the validate button here, it's going to actually go ask the blockchain to get that data back out of it. So that's, even though these seem fast, and that's an example of how fast a blockchain transactions are in this sovereign permission to blockchain. Things happen very quickly.
One thing to note here, this is showing you the data that you put in. The only party that can actually see that data is you. So that's one thing I would have demoed if I had a way to show this is that you don't actually see that information in the blockchain.
Yeah, the reason we could see it is because we made a key for Joe 2000 that we have, but in the real world, Joe 2000 would have a key that goes in all the apps he wants to use to validate himself.
Sure. Yeah.
And then this last step is a step that we're performing on the Scimitar host to further secure their account by removing the password on the host. And then, John, if you want to explain what actually the steps to get into the host for further access would be.
Sure. So we clear the password on the host. We also set a flag on it to say, guess what? We don't care if you have a password. You're not getting in because we're locking you out. We basically lock the application, lock it out, just like they had 3 strikes. So now what's going to happen is he's going to go through and log back in. So now once he's gone, he's set himself up in the sovereign network where he's the only one that can do this. What's going to happen now is it's going to get this little pop-up that says put in your sovereign ID. And before it will do anything, it's going to check with Joe 2000. And Joe 2000's phone is over here on the right. As soon as he does that, it's going to pop up over here and say, hey, is that John Best? Or is that Joe 2000? He did his fingerprint. He did his login piece here that fast, and he's logged in. He could also do this with voice verification. We could also do this with other kinds of biometrics. We could do facial recognition. We could have a lot of different ways. As the Internet of Things proliferates, we'll have different ways to be able to confirm you are you and contact you to say it's you logging in. And the best part is it created a token that only works for this amount of time that's on the host. And when it's done and you log out, we're going to do that same thing. We're going to clear everything out. We're going to lock it, and no one's getting in unless they have the encryption key. And not only that, but another, at this point, 6 computers have to say, yep, this is Tom Stacy, and he's allowed in, which is way better than what we have today. If we did nothing else but get this working to reduce identity theft, to reduce crime, all of those things, we would have a huge win on our hands as a credit union. And also this ever-off identity that you have sponsored them into, or the sovereign identity that you have sponsored them into, is completely free. Evernym is giving this away. There's no, the point here is not to create money. The point here is that if you have this off, it's yours, not someone else's. So what that means is that if we as credit unions, if Suncoast sponsors Joe 2000 in there forever, Suncoast is the guy that brought him into this. If there's another credit union down the street that's also taking sovereign, now they both can use the same login and the same attestations. And if we get enough of us as credit unions, we could actually go to some other big players or even small players. We could go to the local school system and say, hey, guess what, guys? Why don't you use this? It's more secure, it's easy to set up, and oh, by the way, it protects the members' data. And that's how revolution happens. That's how an industry movement happens. But you got to have a blockchain network to do it, which is the CUBlockchain side, and you got to have the ability to have an application that's sovereign, that's encrypted, that's set up. So, Tom, if you want to stop sharing your screen, I'm going to end this because I know we're 6 minutes over. We practiced this, but it did go a little longer than we thought. So, when Tom closes out his screen here, we're going to go to this last slide and talk about the way forward. So for those of you who have stayed around, and I see we've just lost 4, so here's what we have for you is that, first of all, at our AXFI conference, June 26th through the 29th in Minnesota, we will have a meeting. We already have a lot of credit unions, some of the big ones, Suncoast, you saw that, who are participating and exploring this with us. We are going to do the last day. You do not have to join the conference. You don't have to participate, although we would love it if you did. You don't have to do that to be part of the blockchain summit in person and get more information on this there. You can join the movement by signing up at CUBlockchain. And if you thought this was interesting, if you think, hey, 1, I'd like to at least run a node on this. 2, I want to participate in this identity movement. I see the power of this. I see how we could make change here. I see an opportunity here. Then join us for Blockchain Part 2. And there's opportunities to invest. There's opportunities to be part of this. And we're going to be running a second webinar on that. We already have, we had a meeting in Denver 2 weeks ago that had 90 people in it, included some of the biggest players in the industry. And we're very close to, having those folks on board, and you'll recognize those names that are all working with us. The next step is to get more in participation, and that's what we want, is all of you to have a chance to participate in this, not to fracture our world. So that's part of it. You can sign up right now for Blockchain Part 2 at CUBlockchain.com. Secondly, are you a geek? Did you join this because you love the tech? Do you really want to see the bits and bytes? Do you want to get in there and see exactly what Jason's talking about? Do you even understand what elliptical curve 25519 means in encryption? If so, then you're an IT person, there's another place to sign up. We're going to do a webinar. We're also going to do an in-person deep dive review on blockchain, and not just the Everden products. We're going to look at Ripple. We're going to look at Ethereum. We're going to do probably a whole day out in Colorado that we want to invite you to. Are you a CIO who just wants to understand this more? Do you want to get around these people? All you got to do is pay for travel. It's free. So that's our story, and I'm going to take questions. So I can see there's a couple here. I'm going to start off with Dale. So blockchain makes it difficult for a hacker from hitting a single server and modifying data. They'd have to simultaneously hack redundant data on 51% of the network. But it doesn't stop bad guys with keyloggers in the man-middle from taking over and submitting new records into the blockchain records that undermine security. We use the same protections we have today to out-of-band confirmation, nothing new and improved. Do I have that right? I disagree with that. I would say yes. During that registration process, Dale, there is a chance that that we have a bad guy who gets to register into that, and that's always going to be an opportunity. But as we move forward and looking at these attestations, and other people start to do attestations, it's going to be harder and harder for someone to do that. And if you looked at the demo we just did, a keylogger, once you get moved over to the sovereign network, is not going to help you because you'll have to have the key to set up the phone. You'll have to have the fingerprint, or we put that 6-digit PIN in there. It's not our favorite thing, but there are some people. We're actually looking at using that for voice verification. In other words, you say the 6-digit PIN. We're working. We've got lots of groups that want to look at that. I've been talking to a guy at SayPay who has this technology. So there's a couple different answers to that. But I do agree that in this interim step where we're boarding people into the sovereign network, we have to be very careful the hackers don't board the identity in there. And there's that's why we don't have all the answers to this. That's why we're saying, hey, we want more minds on this. We want folks to come in and participate in the committees of CUBlockchain, participate in the governance, participate in the movement, so that we can figure out the rest of this. There are holes that we need to plug, but either way, it's an opportunity to improve it for the vast majority of people. But I do agree that there are people who could hijack that registration process, and we have to be careful about that. Okay, so there's no per transaction cost associated with the biometric, or do online banking solutions need to pay something for every login that gets verified? So monetizing this is important, and there is a lot of different ways to do that. we would rather see this monetized by utility and application and not the authentication. So the idea is if you're going to monetize the identity, could we monetize it with a payment app? Could we monetize it with a lending app? Could we monetize it with those sorts of things so that the home banking platforms and the more generic platforms don't have to pay to play? That said, I don't know the answer to that right now. And I don't think, Jason, you guys have that spun up just yet either, because we want this to be ubiquitous, and that counters that theory. You want to speak to that to some extent, Jason?
Yeah, early on, we decided that we would use a very permissive open source license with what we're creating. Now, we're not a not-for-profit, so we do believe that at some point, and we're talking years potentially down the road, where we're going to want to monetize, but we're going to want to monetize at a place much further up the stack than where Plenum and Sovereign live. And so we're giving this away because we think that if we build it right, we get the right partners, we get the right adoption, then it starts to build on itself. And the network effect of identity across multiple identity providers and relying parties creates a tremendous value in this identity for the members.
So yeah, that was a great question. And so I think he just said it. We're giving it away, and because adoption is key. We get enough of us, you get enough credit in here, we can really do some insane stuff. There's a question from Brian Peterson. I'm going to answer this one. Is the authentication method always going to be the use of a cell phone? If not, what other authentications are designed in this? Okay, so that's a great question. No, cell phone is an option. We're seeing the rise of applications like the Echo. We're seeing other IoT devices. We can also look into, as we talked about, voice metrics locally on the machine. There are a lot of different ways to go. So we did not lock this down to a single endpoint. As a matter of fact, Jason and I were doing some discovery around fingerprints and the alleles that are there with that. And actually, believe it or not, voice verification can be more secure. So can facial recognition. This is just going to grow, and it's related to the Internet of Things. And if you think about the Internet of Things, identity is going to be crucial to that. We can't have things that have us. We have to have us that has things. So this paradigm's got to be fixed before we can move forward too much more. Otherwise, you're going to have a password for every washing machine, coffee maker, blender, and toaster in your house as well. So I hope that answers your question, Brian. Dale, thank you so much for joining. There are a lot more attendees. I'm happy to unmute if someone wants to ask a question. All you have to do is raise your hand, and we can stick around just a little bit longer for more questions. We hope you can sign up right now, today, at the CUBlockchain 2 for the CUBlockchain part 2 of this, where you're really going to get to see a lot more stuff. And like I said, if you're a geek, Jason and I want nothing more than to get a bunch of geeks on the phone, because every time we try to show some screen stuff on it, we get yelled at. So we're looking forward to have the geek dive where we can break up and bring up all the code and not have anybody yell at us. So very excited about that. So if anybody else has any questions, now's the time where I'm going to unmute everyone. So let me do that here. Let me figure out how to unmute everyone here. Is there a way, Ed, to unmute everyone? I think there is. Yeah, here it is. All right.
Muted.
Oh, Ed, I don't know if I can do it. I think you might have to do it.
Unmuted.
All right, let me see.
Muted.
Yeah, I don't see a way to unmute everybody. I can mute,
all right. Well,
not unmute everybody.
If anyone else has any questions, you can always email me at jb at, oh, here's one. Oh, wait, no, that's not a new question. So we hope you'll join part 2. And we just can't thank you enough for coming. We hope you got something out of this. And do not be afraid to email us at info@big-cu.com with more questions. We're happy to answer them. We think this is important.